All right, we are continuing with chapter 3 today. We're doing section 3.2. There's a lot of theorems today. I believe there are 4. They all have to do with perpendicular lines. So a lot of the right angle talk today, 2 lines that form a right angle. We'll talk a lot about those today. Learn some theorems that have to do with what all happens when we have perpendicular lines. Do some examples, do some homework, pretty straightforward lesson. All right, so the first theorem says that all right angles are congruent. So if you know that 2 angles are right angles, you also know that the angles are congruent to one another. They both have the same measure. The measure is 90 degrees. Okay? Pretty easy there. The next one says if 2 lines are perpendicular, then they intersect to form 4 right angles. So typically, if you see perpendicular lines, only one of the angles is labeled with that box. But technically, they're all right angles. So now if you want, you can label them all with the little box, or you can just remember if one of them has the right angle symbol, they're all right angles. That's the second theorem. The third theorem says that if 2 lines intersect to form adjacent congruent angles, then the lines are perpendicular. So basically, if you have 2 lines that cross, and I tell you that this angle equals this angle, the only way that will happen is if they're 90-degree angles. Okay? And then the last one says, if 2 sides of adjacent acute angles are perpendicular, the angles are complementary. So if you have perpendicular lines, right angle, and I cut it into 2 smaller angles, those are going to add to 90. We had that actually on your test that you guys took on Friday. So that's nothing new, but now you have an official theorem to back it up. So just lots of information on perpendicular lines and right angles in this set of theorems. Do you guys have any questions? No. So hopefully you have a good list that you can read again, because we're going to refer back to these a lot today. I'll give you a few more minutes if you're still writing. The directions say that line A is perpendicular to line C. So A is this one. C is this one. We just learned that perpendicular lines actually give us 4 right angles. So I'm going to label the rest of this as being right angles. I also know that line B, so this guy, is perpendicular to line D. So these are going to be all right angles. Do I know anything about the measure of angle 4? No, they did not tell us that any of these were right angles. They look like they're right angles, but we don't know for sure. Now it says, determine whether enough information is given to conclude that the statement is true. Explain your reasoning. So, can we conclude that angle 1 is congruent to angle 2? Yes. Yes, because they're both what?
Right angles.
Right angles. Good. So number 1 is yes, and my reasoning is all right angles are congruent. That was the first theorem you wrote down on the last slide. All right, angle 2 and angle 3. Can we conclude that those are congruent?
No.
Are you sure?
Yeah, you can.
They're both what? Yeah, so it's actually the exact same answer. Yes, because they're both right angles. All right angles are congruent. All right, angle 3 and angle 4. This one we don't have enough information because we don't know anything about any of these angles right here. So this is no, and the reason would be that we don't have enough information. All right, what are your questions?
We don't have any.
All right, number 2. You guys can just follow along with this one with me. It's a lot like number 1, so let's just do them together. So the directions say that line K and line L are perpendicular. So K is here, L is here. So I know that these are all 4 going to be right angles. Okay? Line K is also perpendicular to N, so N is over here. So those are all right angles. I'm going to try to answer these questions, same idea as the last slide. Angle 1 and angle 2. Can I conclude that those are congruent? Yes. Why? Good. So my reasoning is that all right angles are congruent. And notice that I'm using the angle symbol instead of writing the word angle and the congruent symbol for writing the word congruent. It just makes these go a little quicker. If you want to write out the words, go for it. All right, angle 2 and angle 3. 2 is here, 3 is here. Are those congruent? Yeah. How do I know? Same thing, right? All right angles are congruent. 3 and 4. What type of angle is this? What type of angle is this? Yeah, same thing. They're all right angles. Anytime they're both right angles, they're congruent. So I'm just going to put that little mark. It means the same thing. Here's where you would get a different answer. Look at angle 5. Do I know anything about the measure here? No, it doesn't even look like it might be a right angle. It's way off, like it's a slanty line. So this one is definitely a no or a not enough information. You can never just use the fact that it looks like it or it doesn't look like it. So I couldn't say, no, it doesn't look like a right angle. That's not a valid reason. A valid reason is there's not enough information about that angle. Okay? So on these types of questions, look to see if they're both right angles. If they're both right angles, yes, they're congruent because all right angles are congruent. If one of them is not labeled or you don't have enough information, then it's no, not enough information. Okay? Let's see if we can find something a little more exciting. Oh, yeah, here it is. Go ahead and draw the diagram. This one's usually kind of tricky for students. All right, so example 3 says, in the diagram, angle RPS is congruent to angle RPT. Are the lines perpendicular? So one of the theorems that you wrote down, I believe it was the third theorem, states that if two angles are formed by intersecting lines and they're also congruent, those lines must be perpendicular. So this is actually a yes. Now, the reason that I always remember this is, what's the angle measure of a straight line? 180. So if these are congruent, they're the same, and they add to 180, what's the only way that would work? They're the same and they add to 180. So we already know that this is a straight line, right? So these two angles together have to add to 180. They're also equal to each other. So what are the only two numbers? Well, it's one number. When you add it to itself, gives you 180. It has to be the same number. 90 and 90, yeah. So that's why this has to be, yes, the lines have to be perpendicular. It's the only way they're the same, and they also add to 180. If you drew it, that's good.
No, do you draw the number 4 diagram?
If you drew the number 4 diagram, that's good. It's so similar to number 3 that if you didn't, that's fine too. Either way. Example 4 in the diagram, so similar setup, angle GPH is congruent to angle HPI. Now they're asking us, though, if this angle down here is a right angle. Is this guy a right angle? You're saying yes. We need to explain.
So what was the question or diagram?
So is this guy a right angle? We said yes, but now we have to explain. How do I know that that's a right angle?
Because if you flip it and stuff, it's going to be a right angle.
You flip it and stuff.
It's going to measure 90, yeah.
Yeah, so similar to up here, right? These two are congruent. They're formed by intersecting lines. So half of 180 goes here, half of 180 goes here. Everyone agree with that?
Yeah.
So this one's 90, this one's 90. Now, you could use theorem number 2 and say that perpendicular lines make 4 right angles. That's how you would get this guy. Or we've just created vertical angles like we talked about in chapter 2. So you could use vertical angles too. You could use either of the things you know. I'm going to say yes because the lines are perpendicular and perpendicular lines make 4 right angles. I'm not sure.
Nothing's fitting in my book.
This says in the diagram, line AC is perpendicular to line BD. So AC goes this way, BD goes this way. Find the value of X. So this is what kind of an angle? 90. So what do I do with the 2 smaller angles? You add them together to equal 90. So do you see how we have 2 smaller angles? They make a right angle when you put them together. Right angles are 90 degrees. So I add the smaller one, 6x plus 4, to the bigger one, 20, and I'm going to solve for the 90. Okay. What'd you get? 11. I agree. All right, so we added the 2 expressions from the smaller angles together, put it equal to 90, combine like terms, solve for the x using subtraction and division, and I get that x equals 11. Any questions? Theorems, good. About what? Perfect. And you know, I'm all about the shortcuts, so I'm going to use that. So theorems about perpendicular lines.